All right, ladies and gentlemen, I'm going to finish up section 5.1 by um, looking at scientific notation problems. Scientific notation, of course, is a convenient way for representing very big or very small numbers. And the specific format for scientific notation, there's a very strict format. Now, scientific notation numbers, very big or very small numbers, could be positive or negative, depending upon whether they're very large numbers. For positive numbers, like distance to various stars in our universe, are huge astronomical numbers, or they could be negative numbers. Um, also, anyways, the format for scientific notation is this format here, and the exponent on the base 10 here could be positive or negative. Positive for large numbers and negative for small numbers. So, like I mentioned earlier, astronomical distances would be represented by using a positive exponent on base 10, whereas very small numbers, such as the coronavirus, which is going around, is so small you cannot see it with the naked eye. You have to use an electron microscope to see it. At any rate, its size would be represented by using a negative exponent on base 10 here. All right, now this this quantity to the left of the decimal point has to always be an integer between 1 and 9. So this number, this digit here, a to the left of the decimal point here, it could be the number 1 or 2 or 3 or 4 or 5 or 6 or 7 or 8 or 9. It cannot be any other number than one of these guys right here. And so knowing that, that dictates where we move the decimal point to put our number into scientific notation format. Okay. All right. So let's look at a number here. This number here is, let's see, 432,000, which is a pretty big number, but there's bigger numbers than this even. The decimal point of 432,000 is understood, since this is a whole number, the decimal point is understood to be to the right of the ones digit, right here. To put this number in the scientific notation form, we have to move this decimal point to the left so that it's inserted between the 4 and the 3. Now, you would not want to put it between the 3 and the 2, because if you put the decimal point here between the 3 and the 2, to the left of the decimal point, you'd have the number 43. And 43 is not one of these digits that this number has to be to the left of the decimal point. You could not put it between the 2 and the 0 here, because to the left of the decimal point, then you would have 432, which again is not a 1, 2, 3, 4, 5, 6, 7, 8, or 9. Now, you could not put it to the left of the 4 here, because if you did so, the digit to the left of the 4 is understood to be a 0, and 0 is not in this list that's mentioned up here. So, ladies and gentlemen, the decimal point has only one place to go, and that's between the 4 and the 3. So, how many places to the left must we move the decimal point to get the decimal point between the 4 and the 3? Well, we count 1, 2, 3, 4, 5. So we had to move our decimal point 5 places to the left to place it between the 4 and the 3. So therefore, in scientific notation form, this number would be 4.32, and you don't have to list all the zeros after the 2, times 10 to the positive 5 power. Positive 5 power on the base 10 because we moved it the decimal point 5 places to the left. And notice the exponent is positive because this is a big number. 432,000 is bigger than the number 1. Okay? All right. Let's try another one here. Suppose we had a small number, negative 0.000346. This is the tenths, hundredths, thousandths, 10,000ths, 100,000ths, millions. So we would read this as 346 millionths, okay, which is a very small number because one whole is way up here. So this number is much smaller than one whole, all right? Now, to put this number into scientific notation form, we have to move the decimal point where? Remember, to the left of the decimal point has to be a number which is either a 1, 2, 3, 4, 5, 6, 7, 8, or 9. So the only place that we could move this decimal point to ensure to the left of the decimal point we would have, one of the aforementioned digits, we would have no choice but to move our decimal point between the 3 and the 4 right here, because to the left of our decimal point then would be the number 3, which is in this list up here. All right. So how many places to get it to between the 3 and the 4? Here we go. Let's count. 1, 2, 3, 4 places to the right. So we had to move our decimal point. We had to shift it 4 places. So therefore, in scientific notation form, this number is going to be negative 3.46 times 10 raised to the negative 4th power. Now, we have negative 4 on our base 10 as the exponent because we had to move our decimal point 4 places, and it's a negative exponent because this number is less than 1 whole. It's a small number. So again, small numbers have negative exponents on base 10. Large numbers have a positive exponent on base 10. Okay. All right, so hopefully that makes some sense there, how we put numbers into scientific notation format. Suppose we wanted to go backwards. Suppose that we wanted to take a number that's in scientific notation form and put it back into ordinary decimal notation form. Well, let's look at this. So if I add negative 3.52 times 10 to the 5th power, suppose I want to take the scientific notation form number and put it into ordinary decimal format, or sometimes they call it standard format. Notice we have a positive exponent, and because we have a positive exponent, ladies and gentlemen, you're going to shift your decimal point to the right to put this into standard decimal notation. So to the right, we're going to have to go 5 places. So this decimal point here is going to have to get shifted 5 places to the right. All right. And so to put this in standard notation, I'm going to bring the negative sign over here, and I'm going to bring the 3 over here, and then the 5 and the 2, and now we must go 5 places to the right from where the decimal point was. So here we go. 1, 2, 3. Now we got to add a 0 here. That was 3, and here's 4. Add another 0. 5. Add another 0, and the decimal point goes right here at the end. And so that would be your answer in standard notation or decimal notation. So this number is now negative 352,000. Okay, that is negative 3.52 times 10 to the 5th power in scientific notation form. So again, we went from scientific notation form to ordinary decimal form, or standard form, as we oftentimes refer to it. All right, let's look at another one. 7.53 times 10 to the negative 4 power. Okay, let's write this number, which is in scientific notation form, in ordinary decimal format or standard form. Notice our exponent here is negative. Okay, and because we have a negative exponent, when we get done writing this number in standard form, it better be a number that's less than 1 whole. Okay, so this pertains to a small number. All right, now to write this number in standard form or decimal form, we're going to have to shift our decimal point 4 places, not to the right, but to the left, because we have a negative exponent on base 10. So therefore, we're going to go 4 places to the left. Now, I'm going to put the 753 way over here to the right of the equal sign. Now, my decimal point originally was between the 7 and the 5. Now we must go 4 places to the left. So here we go. 1, 2, got to add a 0. 3, got to add a 0. And then 4. Must add another 0, and then the decimal point would be right here. And so that would be the number in standard decimal format. It's 0.000753. And it's optional. You don't have to do this, but nurses always put a 0 that precedes the decimal point to stay off any errors when doing dosage calculations. So normally we get in the habit of also putting an optional 0 here. Okay, there you go. And if you want to read this number formally, this is the tenths, hundredths, thousandths, 10,000ths, 100,000ths, millions. So this would be 753 millions. Okay. So hopefully these examples show us how to go from standard or decimal form to scientific notation form. and then how to go backwards from scientific notation form back to decimal form. That concludes this video.